Hey. Welcome everyone. Today we continue working on leetcode problems, right? Refreshing our knowledge and preparing to potential interviews. Yeah, for those who are new, I'm software engineer at Microsoft, working here for I think almost 3 years already. Yeah, and exactly 3 years ago, I was on the same stage preparing to leetcode questions exactly same way as we are doing today. Maybe somebody would find it useful. Last time we did a pretty good job. Last time I think we solved up until string compression problem, which is pretty solid, I would say. Okay. Let's see how it goes today. Currently I'm in the office. Yeah, prepare yourself a tea and let's go. Let's go solve some leetcode. Meanwhile, as it was before, feel free to ask anything. We can talk about anything. Чему не в окопі? Я ухилянт, братик. Я ухилянт. So, our problem is string compression. Let's start with this one. It's medium one already. And yeah, we have array of characters chars, compress it using the following algorithm. Begin with empty string for each group of consecutive repeating characters in chars. Okay, so basically this is, yeah, our goal is to write simple compression algos when we have some string and we compress it to smaller string. Basically what we should do is for repeating consecutive characters, we so for repeating characters, instead of this repeating sequence of characters, we should put just the single character and the number of times it is repeating. So, for example, in this case, we have AA, so it's 2A, we should put A2. In this case, we have 2B, same way. And in this case, we have C3, and we put it C and 3 as a character. Okay, but there are some rules. There are some rules still. So, for example, if the group length is 1, append the character to S. Return 1 is a... And this one I don't really understand. Like, it seems like we should return number. So what do we need to return? I'm sorry, I'm a bit lost. It's already evening and we need to somehow to start our engine. Begin with empty string. Should be returned separately in the input character array chars. Okay, so we should actually do this compression in place without creating extra strings, which is yeah, I will do this one. So yes, it should be done in place, as is stated here. We should return the new length of array. Okay. So basically, as I understand this, we should move through the array, and whenever we see consecutive sequence of characters, we compress them and we put just with numbers, and we should return the length of resulting array, which is in this case should be 6, right? And constant extra space. Okay. I hope I understood it correctly. So yeah, as it was previously, we are using Vim motions with Visual Studio Code because yeah, Vim is a great thing. After I think 6 years of my experience, I'm done with using mouse. Now I'm using only keyboard. Good. So yeah, let's start this thing. So this is array string. Good. So what we can do, we basically can move through the array, and whenever we see the repeating characters, we count how many of them. So we start with A, we continue until we reach B. We see that A is actually 2, and we are writing A2 into the resulting array and also increasing separately the length of the resulting character. This is the way I think. Yes. And also, can we have more than 10? No, the group lengths that are 10 or longer will be split into multiple characters in chars. So I think we will have only one number. The group should not be longer than 10 characters of the repeating ones. So yeah, first of all, since when we reach the B, okay, when we reach I think the C, no. Yeah, so we should maintain the something called write index, which should start at 0, because this is the index when we're gonna write stuff. Append the characters to S. Yeah, and now we should iterate. Hey, do you stream every weekend? For now, yes, it seems so. I'll be doing it every weekend. Let's see how it goes. So yeah, we are maintaining something called write index, and we should basically iterate over the whole string. Yeah, let's also define the just regular indexes that we're gonna use for iterating the whole string. It will start from 0 and it should be always less than char's length. Yeah, so far it's constant space, as it stated. Now what we're gonna do is so we have some character on the current index. Okay. And we should count how many times does it repeating. So in this case, it's A on the 0 index, and we should keep counting until we reach B. So in this case, we are doing this one. If index less than char's length and char's index equal to our current character that we got, we keep moving our pointer forward, and also we are counting the reps for this character. So we start with 0. It always should be at least 1, right? Because at the current index we already have some character in it, and it's already 1. Yeah, reps plus plus as well. Now, what should we do? We should should it be first the character or the number? No, first is the character, which is even simpler because right now what we can do is we can write to our array the characters that we were processing, I would say. We are putting this character, and only in case reps is more than 1, because it is stated here its length of the group is 1. So in case we don't have 2a and we have only 1a, we just put a and that's it. So here we don't change anything, we just put a as it is and return 1 as it is the length of the array. So only in case it's more than 1, which is 2 a's, 2 b's, 3 c's, we also append, yeah, this index should be increased. We also append it here, write int, also plus plus. We should increase right after we wrote there, and number of reps. Exactly. So this way we did it. Yeah, okay, and now I'm just thinking after this while it should be either we reach the end of the string or it is already different character. So we should just proceed as it was before. Yes, I think we don't need to do this thing here because we don't want to miss the next character. In this case, it should be B. Let's try to run it in my mind at first, and if it goes well, then yeah, we would go and yeah, and try. So let's check this one example. So at first, index is so at first our index is here. I'll put this one, yes. So at first our index is here, and right index also is basically here. Yeah, right index is here. Good. Then we proceed. We take character A. Reps is 0. We should actually, sorry, and in the end we should return the length. Return right index plus 1. Because yeah, right index increasing every time we are writing to the array. And yeah, in this case it should be 6 because we would stop writing on this index. So right index is here, all's good. We take A. We keep iterating, so this index moves here. Yeah, we again iterating, it moves here. Reps is equal to 2. We are writing here our character, which is A, and move this index forward. It will be here, and also since it's more than 1, we are writing also not resp but reps. Reps, exactly. We wrote reps, so here it will be A, and here it will be 2, and right index already moving ahead. Same way we are doing with B, same way we are doing with C. Yeah, should be working actually. If it's length, good. Yeah, should be working. Let's try it out on the simple test cases. Yeah, let's go. No, it's not correct. Let's see what went wrong. Okay, it's interesting. I'm sorry. Yes. Most probably because we. Yeah, JS. Okay. Yeah, it put the. Whenever we are writing the reps, JS understands that it is basically integer, and it does not put it as a character, but it puts it as a number. So I think we should do this to string. Will it work? Let's just check it straight away in the same tab. And to string. Yeah, works. Let's try now. Now should be working basically. Okay. So they actually want me to. So this is basically a lie. It can be more than 10. And they want to have the separate characters. Well, okay. In this case, let's. So I hope you understand what's going on. So now the number of reps is more than 9. It's two-digit number. It's more than one-digit number. It can be even three-digit number if there's like 100 of the same characters in the group. And in this case, we want to not put as a single character, but instead of like this, we want to do this two separate characters. So we can just write in character by character. We don't care. We don't care much. Let's redo it the same way. So here, in case we have more than one reps, what we should do is to basically put it as a separate. Yeah. So the simple way of doing it would be to put reps to. Yeah, a simple way to do it would be is to put reps to string, which would give us, instead of digit number, it will give us string, and then we can slice it to an array by using split. Let's also check it straight away. So in case we have this one, we are applying to string. Okay. Let's do this to string and then split on empty. Yes, this is exactly what we want to do. And then we want to append each of these characters. Good. So I think we need 4 here. Subcharacter of this shit. Yeah, to string, split, yes. And here we are putting character, subcharacter. Good. Let's run it. And our cases are good. Yes, pretty much solved. Regarding the complexity analysis here. So we are iterating over a whole characters array, which already we can state it is O(n), big O(n). Then here it can be a bit tricky because you actually see nested loop inside the main loop, which kind of can say you that this n squared, so n power of 2, but actually it's not, because if we think about how many times each index in characters array would be visited, it will be only one time, because index in this int instance always strictly increasing. So we will basically visit every index only once. So it's O(n) actually. And regarding the space complexity, it is constant, but with some tricky part here, because whenever we are putting the string, we are creating string which is the size of reps. I don't know how many it can be. It seems like this description isn't true actually. Okay. So this is not what guarantees they provide. This is what we should have done. Okay, I just misread it. Anyway, so this would create extra space of whatever the length in the reps number. So we have 100 repeating characters. It will be a string length of 3, and it will create array. So 2 of whatever this number. But we can actually forget about this, because this can be actually approved by having mass, like dividing by 10 and writing in it, blah blah blah. But let's just not care about it. We can basically skip it. Big O. Good. I think we can move to the next question. I think we are switching topics right now. Yes, it's move zeros. It's 2 pointers problem at this point, which is interesting one. So we are given integer array nums, move all zeros to the end of it while maintaining the relative order of non-zero elements. Oh, this is actually a cool problem. Could you minimize the total number of operations done? So what we can do, let me open maybe Escalidraw. And yeah, people were asking last time to have some drawing. I think it's not a problem, we can do it. So yeah, let me put my Escalidraw here. So basically, oh no, it's wrong problem. Yes, this move zeros. We have this one. Okay, so we have this. Let's write it as a separate 0, 0, 1, 0, 3, 1, 2. Yeah, let's move them, and I'll show you the brute force approach that can be applied here. Oh, it's actually 12. Okay, let's put it as a 12. So what is asked from us, that we should rearrange this array in the following way, that all zeros would be in the end, but the order of non-zeros characters is the same. So one of the approaches that can be done is basically whenever traverse the whole array, whenever we see some 0, we just trigger a swapping function or whatever it is, and we swap this 0 with every single character until we reach the end. So we are doing this, swapping, 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 and put it to the end. It was this index on the one, we move to the next one, it's again 0, we're again swapping it, blah, 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 swapping, swapping, and swapping again. And then we reach 12, it's not 0, we skip it, then it's 0 again, we again swapping, and then last 0, we're again swapping at the same place, and we are done. This is our array. Complexity in this case would be n times n, so n squared, which is not actually good one. It would be great to solve it in O(n). How I can do it? Pretty easy. What is Microsoft SE? I'm sorry, I missed this question. This is software engineering. Yeah. Sometimes, actually, in thanks there are multiple acronyms or abbreviations for this one. So actually, I heard that Google has a lot of SREs, which is Software Reliability Engineer, which is basically DevOps and on-call person. At Microsoft, we also have on-call, but we are not SREs. We are doing features, we are rolling out stuff, we are doing like technical depths, developing something and stuff. But also we have 2 weeks of on-call whenever we are kind of SREs. We are responsible for deployments, we're responsible for handling incidents and stuff like this. So this is SREs, and sometimes software engineer is called also SWE, like software engineer, or SE, like which is software engineer. These guys usually, like it depends, they can have multiple responsibilities, but at Microsoft, unfortunately, I think a lot of orgs just don't have QAs. So you are responsible for testing of your code, and you're responsible of deploying and rolling out your code as well. So you're also doing a lot of DevOps shit, a lot of automation testing and stuff, a part of the features. Yes. So, what's wrong with the chat? Why it doesn't show new messages? Okay, this is why. Good. Okay, sorry. Yeah, it is. We have 2 persons in Twitch. Good. Wanna try distribute money to maximum children next? Yeah, we can try it in the end, not the next, because we have kind of plan of what we're gonna solve. We are moving through this list one by one, consequently. But in the end, we can try, yes, of course, for sure. Good. So let's move back to our problem that we are solving. Yeah, thank you, Arthur, for helping with this one. Yeah, move all zeros. With this swapping algorithm, it will be big O n power of 2, because we will be traversing each one, and in case all of them are zeros, every time we meet 0, we put it up until the end, which is traversing again the whole array and moving in place all the elements. How you can do it in other ways? So basically, what we do care about is about order of the numbers. So we should maintain 1, 3, 12. We cannot do 1, 12, 3. What we can do, we can just traverse all array and write the numbers to some separate array whenever it's non-zero. So we can traverse here and create another array where we will be putting, okay, it's yeah, this one. We meet 0, we skip it. We meet 1, we put 1 here to our result array. It's again 0, we skip. 3, we put, and 12 we put. And then we just keep counting how many zeros we met so far when we reach the end, and we put this amount of zeros to the end. So just 2 zeros. That's it. It will be runtime complexity in this case will be O1. But if we keep separate array, it will be O1 and O1 space complexity, because separate array requires you additional space. But what we can do instead, we can straight away write to the exact same array that we got as an input. And in this case, we can omit this O1 space complexity, just get constant. Algo stays the same. We will be just changing the elements inside the array. The number will be the same, so we don't need to resize and do anything else. So let's just implement it. It's an easy problem, too much time spent on it, I think. So move zeros. Let's try straight away with this kind of advanced thing. So we have for sure our zeros count, which is 0 by default. Then we iterate over the array. If current number is 0, then we just increase zeros count and we skip it. Also, let's put our write index to 0. This is the index how we would be writing the elements back to the input array. It will be different from this index, because whenever we meet 0, we actually skip. So in this case, when we meet 1, we will be writing 1 in the beginning. Then whenever we meet 0, we skip again. Whenever we on 3, we should write 3 right after the 1, so on the second index. So these are kind of two different pointers we should maintain. One pointer is responsible for just traversing the whole array, and another pointer, which is write index, is responsible for just writing the correct response back to the input array. So this kind of optimization. So it's zeros, we continue straight away, we don't want to proceed. And in other case, we just performing write. And we're moving this index straight away forward. Then in the end, while zeros number is more than 0, we just keep writing. So we just remember how many zeros and we put them to the end straight away. And we are doing it up until zeros number is not ended, not over. In this case, what should we return? We should return the array, right? So we just return input, the same one that we received. Basically that's it. Good. Let's try. Wrong answer. Interesting. So we missed 12 somehow. Okay, let's check how it can be possible. So we counted 0, 0 here. We wrote 1, 3. We put 12. I'm sorry, yes. We should move the right index forward as well. Whenever we are writing, we are moving it forward. Yes, now it should be okay. Good. Yes, one more is done. Each subsequence. Let's move forward. So in this case we have, let me prefill the code. In this case we are given two strings, s and t. Return true is s is subsequence of t or false otherwise. Subsequence is a string, is a new string that is formed from the original string by deleting some or none of the characters without disturbing the relative positions of the remaining characters. S is a subsequence of A, B, C, D, E, while A, E, C is not. Yeah, so basically, yeah. So we should maintain the same order, and we should, yeah, how we can do it, we can just remove some of the characters, and this is how we create subsequences. Good. So brute force solution, which is n squared, is not good here. So how I can, what is the brute force solution in this case? The brute force solution here would be, we just trying every possible subsequences and see in T and check if they are equal to S, which will give us n squared, because how we're gonna do it, we try AH, AB, AG, AD, AC, these subsequences that I was hovering. Then we start again with H, then HB, HG, HD, HC, and so far, and so on. It is not good algos in this case. It will give us n squared. It's not that complicated, just two for loops, substring, and checking whether S is equal or not. We can do better. We have already kind of hint in the description that subsequence is basically removing some of the characters. And we for sure know that the order will be the same and should be the same. So basically we can just, how we can proceed, let me draw this as well. So let's say we have A, B, and what else? A, B, C. And we have A, B, C, D, E. Or no? Okay. We have A, we have H, we have G, D, and C. So how I can proceed in this case? We want to say whether ABC is substring of this A, H, B, G, D, C. We can start with the first ones, so we keep indexes in both of these arrays, and we can start whether characters under these indexes are the same. So in this case we start with 0, A and A are the same, and we move both of the indexes forward. So one index would be here and one index would be here. So in case they are the same, we are moving it forward. And now we're checking H and B. Are they the same? Well, no. But we should remember that this is our string that we should get as a result. We should prove it. And then we move the longer string, because, yeah, the longer string is the one that we are trying to remove characters one by one. We move J here. We check, is the character under J is the same as character under I? Well, yes. In this case, we move also this index in the substring array and move this one. Then we keep this process and check, is G same as C? No. Moving it here. Is D same as C? No. Moving it here. And eventually, yeah, it's equal. And we're moving it to the end. And the way we can understand that we are done in this subsequence is is possibly here or not is by telling if the I is in the end. If I stopped here and there was no C, instead of C it would be E, for example. Oh shit. Like this. And C is not here. Then in this case, let's move back. We reach the B, we keep moving. We reach the B, we moved both of them, and then we keep moving the J. And whatever we see, it does not equal to C. At some point we are done with this array. And I is not done. So I is not equal to length of ABC. And in this case we say that, yeah, ABC is not actually subsequence, because after the early B, we didn't meet any C in this longer string. Hey, Aditi Hinge, I'm sorry, maybe I pronounce it not correctly, but yeah, for brute force use recursion. Well, in this case, I don't think we need a recursion. Pointer won't be optimized to for loops. Yeah, brute force would be 2 for loops, but we can do better actually with just 2 pointers, and 2 pointers will give us O of M if M is length of this longer string and N is length of smaller string. So we're basically iterating over this M. Always we would traverse it in case to see if this is a subsequence. Maybe if we see that C is here a bit early, so in this case we move both of them here, and in case we see that I is already done before, we might omit traversing these guys here and just return true straight away. Also possible. Let's implement, again, too much time on the easy problem, I'm sorry. Yeah, so the longer string is T, so we're gonna iterate over it. But also we keep track of the index on string S. Let's name it index. And here, pretty simple. If Si equals to Ti, basically in case characters under these two are the same, we are moving this index and this index. So since I index will be moved anyway by for loop, in this case we're just moving the index. Sorry, no. It's S index. This one I and this one is index. Yeah. They are two different indexes. Yep. And in the end, we should just return whether index. What is our criteria is whether I index is equal to length of the array. So index equal as length. Right, it should be boolean, yeah. Yes, pretty much it. Let's actually try this out. Yeah, it works. Good. But it's easy. Let's move. Oh yeah, this problem I like so much. I think exactly 3 years ago, and before that I think maybe 4 years ago or 5 years ago, something like this, I was approaching this problem twice, and twice I failed to solve it in something more than n squared before. Now let's see it. Very interesting problem. So we are given integer array of height, which represents this pillars. What is it, the word pillar? Yes, which represents these pillars. And there are n of them. And we should find the two lines that together with the x-axis form a container such that the container contains the most water and return the maximum amount of water a container can store. This is very good visual representation, which will help us a lot. How difficult is it to get into Microsoft? What unit did you go to? So to get to Microsoft, I can tell you my story. Basically, I think it was after COVID time, 2021, in autumn. I got contacted by two recruiters. One is from Amazon and the second one is from Microsoft, and straight away for sure I said yes. Like, let's try. It was my dream anyway. I was planning to get to some things. But that time I was in some like outsourced company called EPAM. And I started preparing to the interview. So just leetcode and system design. With system design I was pretty good already, so I didn't put that much effort. But yeah, leetcode was a problem. It was my weak part. And my weak point. At Amazon I got rejected, and at Microsoft I passed the interview. Overall I was preparing something like 2-3 months. Yeah. And uni I finished Ukrainian university. I don't know, this one. It is in Ukrainian, but yeah, just regular technical university. I got bachelor and then master's there while I was working basically. Okay, so let's brainstorm this problem. The brute force approach would be pretty much easy now if we just try every possible pair of pillars and maintaining the maximum area that we can get out of them. We can actually implement it straight away here. It would be basically 2 for loops. Yeah. So we're starting with the first one. And up until the one before the last one. I'll explain later why. Yes, so basically we are starting our two. Let me do this thing. This will be easier. So what we are doing, we are starting one index here and one index here. We never want to start indexes at the same pillar, because then like there will be no square, because we also do care about the width property. So we want to try every possible width here. So we're starting with this one, then we're starting with this one, then we're starting with this one, and so on. We try every possible one. Then when I moves forward, we are trying this one, this one, this one, and like up until we try every possible of them. And we never want to have I and j at the same position, because then width will be 0, and we don't want. So I range is this one, and j range is this one. This is I range, this is j. And last one we will finish on these 2 pillars and check them. Good. So let's now implement this. It will be time limit exceeded for sure. Yeah, so this is, let's check the height of the left one. We can do left height, and right height would be height j. Then the area would be it should be which one? It should be j minus I. So we are taking the width and times mass minimum of two of them. Exactly. This is our area, and we also keep maintaining maximum area. We'll start with 0, whatever. And now we put max area is equal to max area, and this area that we just tried in this iteration. In the end, we just return max area. Very bad solution. Let's just prove that j minus I would work. In this case, the indexes would be 0, 1, 2, 3, 4, 5, 6, 7, 8. Let's check what will be the area of these two. J would be on the index 8, and I would be on the index 1. So 8 minus 1 would give us 7. 1, 2, 3, 4, 5, 6, 7. Yeah, it should be correct. And some basic case, in case let's say this is our thing, 1 minus 0 would be 1, 2 minus 0 will be 2, and 2 minus 1 would be 1. Yeah, so basically regular mathematical induction kind of proves that this would be our width. Let's try the solution. Let's try it. Yeah, and try to submit. For sure these simple test cases would pass. Not even a question. Yeah, and yeah, whenever we get some bigger input, for sure we cannot do it. We cannot do it. Okay. Why? And what can we do better? In this case, it's big O n power of 2, which is n square. Complexity, which is pretty bad. Since it's medium problem, we want something better. Maybe some n log n, or just linear time if possible, just O of n. In terms of space, complexity is constant. We don't use any extra space, right? Good. So now let's brainstorm it a bit and think how we want to proceed. What we are interested. Damn, you made this question look easy. Thank you. Yet no, because let's now think about linear solution. So in terms of area and in terms of mass, what is the area? Area is height times width. This is our area. And we can maximize our area by increasing width or increasing height or increasing both. The more both of them, the better. But we can see that whenever we narrow and try some narrower things, we kind of decreasing our width. The best width that can be done is this one. So basically the array length. Whenever we are moving it narrower, the width would be decreasing. Like this width would be just 2, comparing to, for example, this one, which is 1, 2, 3, 4, 5. But by moving narrower, it is possible that we will meet some pillars which are higher, and that would give us higher height, and therefore it will be bigger area. For example, let's check. This two has 8 as a height, and the length of them is 5. So 5 times 8 would be 40, right? Let's check this example, when we are taking these two, it would be 8 minus 0, it would be 8 at the length, the maximum possible width. And about the height, we're taking minimum of 2 pillars, which would be just 1. It would give us 1. It would give us 8. So in this case, yeah, sorry, 8 and 1 works much worse comparing to 5, sorry, to 5 and 8. Now, the question is how we can kind of prove that we will not miss this specific combination of two pillars that would give us the best possible ratio of width and height. This is a very good question. Let's just try to come up with this from the single examples and use kind of mathematical induction to the bigger rule coming from single examples. Let's take a look on this first one on 0 index and this one on 8th index. We know that the maximum possible height of both of these is 1. So this will be our area. Now, we using greedy approach and trying to get as much as possible weight, which is the whole length. Now, how we should move these 2 pointers and which pillars we should then check. Let's think about right pillar. So the height of it is 8, and maybe here would be some higher one or lower one. We don't know, right? We never know. But no matter whether it will be 1 or it will be 10, it doesn't matter for us because we are taking minimum of them. And we for sure know that if it's 10, we would take 1 as the baseline because left one is 1, but we would have 1 less width here because we would move this pointer to the left. And by thinking greedy, it doesn't make any sense because, yeah, if we even hope there will be higher one, it does not matter. It will be 1 as a maximum, as a minimum height, sorry. So in this case, whenever we have index here and here, by greedy approach, it makes sense only to move the left index to the right, because then we can hope that if this one is at least 1 more, just 1 more, it will make both of them to have minimum height equals to 2 instead of 1. And in this case, it will be 8 minus 1, which is 7, times 2 equals 14. It will be already better than 1 times 8. So, by having this in mind, it seems like it's always better to move the index which has less value than this one that has bigger value. For example, in case of this, whenever we have left index on the index 1 and right index on index 7, this is 3 and this has height 8, which is minimum of both of them would be 3 anyway. So no matter if we move the left index to the right, like if it's even not 8, if it's even 1000, the minimum one would be 3 and we will have just 1 less width point, which is bad. So the greedy approach here would be to move right index to meet the left index, because in this case, if it's just 1 more than 3 or maybe 2 more than 3, we will have much bigger area in this case by just sacrificing 1 width pointer. And this is basically the solution. You can run it in your mind and see what will happen, blah, 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 but this is the optimized solution with 2 pointers. And basically, yeah, during the interview you can prove it like this, that the most logical thing that you can do is to move always the last index, and that's it. Also in this case, you might think that, yeah, maybe when I have left index that has a value 8, maybe it would be much better to move 7th index to 8, because then we would have more width, and then we will have maybe even more height. We don't know, right? That's true, but the thing is that we should have already tried this approach. So this case actually is not possible. No, it is possible. No, sorry, it is possible, but it means that we already tried this approach because we are starting from the rightmost index, right? So we kind of already visited this pair, and we already done with it. We keep doing this algo until the indexes are next to each other. So whenever I plus 1 would be equal to j. Good. Good. Let's code the solution then. So, sorry. We are starting with left index equals to 0 and right index equals to height length minus 1. That's good. And we are trying to do our algorithm until left is less than right, which is good. And now what we are doing in this algo, we can basically reuse the same code. We are taking two heights, then we are calculating area, and maintaining the maximum possible area so far. But now how do we move the indexes? This is the interesting part. As we said, we should move the index that has the smallest value among two of the indexes. So in this case, if left height is less than right height, which means the left value is less than right, we're moving left one. If it's equal, or if it's the other way around, so right index is less, we are moving right index. But not plus plus minus 1 is because we want them to meet at some point. And when we meet it, it's kind of done already. Yeah, basically, yeah, this should work. And in case we have same, also this case, because we pretty much know what to do when one index is less than the other one value under the same index. But what if they are the same, like in this case? In this case, we basically don't really care which one to move. No matter what we do, in the end, algorithm will sort it out. So let's say we move the left one here. It will give us this one. And then we would be still moving this one, hoping to get to the 8. We will move it here. Oh, sorry, not this one. We'll move it here. We again will be moving it until we reach this point that they are meeting each other. Or let's say we choose to move the right index in case of they are equal. Then we would go here. This area, well, this one is still smaller. We're moving here. This area, okay, this is a bit bigger. Let's see. We are moving again here, even more smaller, and even more smaller. So in either case, we kinda check every possible state. Because whenever we move left or right, these are equal. So it means it does not matter whether we check area like this or no, actually it matters. But the algo itself is proven to work, so it should be fine. It should be fine. Let's just check it. Yeah, sure. We should do that. Okay, let's correct straight away in place. Yeah, we don't use I and J anymore. We're using right and left. And again, yeah, J is our right, I is our left. Good. Yes, it's correct. Yeah, we passed it. Good. This is good. One more question. So let's try max number of k-sum pair, and I think I need some break for a couple of minutes. So I will just write like this. Okay. Break is over. Let's go again. So we have our next question, max number of k-sum pairs. So you're given an integer array nums and an integer k. Good. Return the maximum number of operations you can perform an array. And in one operation, I can pick two numbers from the array whose sum equals k and remove them from the array. Good. Yeah. I think this problem has multiple solutions. Let's call here. Yeah, this problem has multiple solutions. And basically, during interview, you should mention all of them and ask interviewer whether I should proceed with the solution or not. Let's brainstorm first the solution itself. So we have, yeah, let's move to escalidraw. Yeah, let's move here back. Let's say it's 1, 2, 3, 4, 5. 1, 2, 3, 4, and k is equal to 5. K equal 5. Good. This one we just move. Good. So what is asked in the question and what are the instructions? We have array and we should pick up two numbers in the array that can add up to k, which is 5, and remove this number straight away from the array and keep going it until we find all the possible numbers, all the possible combinations of numbers and pairs that can add up to k. And whenever we add up them to k, we maintain the counter of how many k's we found already. So in this simple case, we want to have k equal to 5. So 1 and 2 would be equal to 3. 3 is not 5, right? 1 and 3 will be 4. 4 is not 5. 1 and 4 is 5, which is our k. We are removing them. We are left only with 2 and 3. 2 and 3, 5. We also remove them. And we found basically two such pairs, and we should return 2. Let's get this example over here. I don't need to paste just paste me the text. What? Okay, fuck it. I will just write it. Maybe this way it will work. Come on, okay. Very strange, but whatever. 3, 1, 3. Three, 1, 3, 4, 3. And k is equal 6. Let's check this case. 3, 1, 3, 4, 3, 3, 1, 3, 4, 3, k is equal to 6. So we want to find all the pairs that add up to k. In this case, we see 3, 1, no, 3 and 3, yes. We remove them. Then 1, 4 is 5, no. 1, 3 is 4, not 6. Again, 4 and 3 is 7, not k. So we are left with this array. And we have only one such operation. The key point here is we don't actually need to return the result in array, which is this one. So otherwise, removing items from the array is n complexity. Whenever you're removing element from array, you should reshuffle it. And you should change the length. So most probably you'll be creating new array. In this case, we don't have to. We should just return the number of operations. But how we can make sure that we don't use the same number that we already used, because we should somehow emulate this case that we removing the elements, right? So in this case, it will not be possible, but in case here would be another 4, let's say. In this case, if we remove in 1 and 4, 2 and 3, it's only 2 pairs, 4 is just left single. But if we don't change array in place, 1, 4 and 1, 4, which is 3 separate numbers, can give us 2 pairs, kinda, if we iterate it in the wrong place. So, the first brute force solution would be always to try everything we can possibly try. And okay, the first solution would be to try every possible pair of characters, and if the sum of this pair can be equal to 5, we just keep counter, and we always tracking what we have already visited. If we visited some index, we just continue traversing forward, because this character should be kind of already removed from array. We cannot use it anymore. How I can implement it? It's a very bad solution. Most probably we will hit time limit exceeded again. So how it might look? We have some set already visited. We have our 1 for loop, which is I equals 0, I less than nums length minus 1, because again it's the same thing. We don't want 2 indexes to be the same, because we should have pair of 2 single separate numbers. This is the P question. Actually, no, it's not, because there is no kind of clear way of defining subproblem, or in the other sense, well, we can do it with subproblem approach and with the recursive way. For example, this is our problem, right? Whenever we found some, let's say 2 and 3, this is our subproblem. So let's, oh shit. Yeah, so this is our problem. We're removing 2 and 3. And now we are dealing with this subproblem. Then we're removing 1, 4. And then we are dealing with this subproblem. Kinda yes, but if you think about it, every previous subproblem cannot be reused, and we will not hit it ever else. So it's not possible that we would meet this subproblem again, because of the nature of the question itself. So yeah, let's implement our small brute force, just to show that yeah, it won't work with the medium question. So j, we are taking always I plus 1, j less than this one. Good. And now, yeah, now what we are going to do, so if nums I plus nums j equal to k, which means we found 2 pair of numbers, we should mark both of them visited I, visited, it's odd, right? Yes, it's odd. We are putting this one, and we are putting also this one. Oh, sorry, why do? Yeah, we just track the indexes. Exactly. Which means we should, whenever we put it to the visited, we cannot use this number as a left pair as a left and as a right. So this number, this index cannot participate anymore. How we can ensure it? Whenever we are in this for loop, we should check it. We just skip such cases. And also we are asked to track how many operations we can perform. So this is exactly what we are doing. We should increase count here whenever we found such number. And in the end, we should return this count. Yes, with this kind of approach, yeah, we can replay the array that will be left. So in this case, this one, but we are not asked in our question. Let's try this out. It passed the basic test cases. Yes, and for sure we hit time limit exceeded. This runtime complexity in this case would be n power of 2, because we're iterating through the whole nums array twice with this 4 and with this 4. Yeah, we have kind of optimization, but we anyway hit this optimization every time. Fajno, дякую. Yes, I use list instead of set. Yeah, it also, like, you can use list, no one forbids you, but you know, then to check whether the list has some index or not, you would need to have O of n complexity. So if each of these call would have additional O of n, which kind of worst case would make it not n power of 2, but n power of 3, which you don't want to hit. Not the add one, but has one. This one will hit us off 2 times n. We don't want this, that's why we are using set, because hash set gives us a constant time of checking whether element is in the set or not due to hashing. Good. So it seems for this problem n times n is not good enough. How you can do it another way? Let's move to the description and brainstorm it a little bit more. So, can we somehow, we already see that it is 2 pointers problem because we are using 2 pointers, and the problem is that we should know which pointers we for sure want to skip and which pointers we actually want to proceed with, and how to not miss the right pointers, right? Whenever we are starting from this one and this one, from the beginning and up until the end, how we can ensure we don't skip the right numbers, and how we can still ensure it is kind of O(n) complexity. So first thing that can come up to our mind is the mass. Always use the mass. Whenever you have some a plus b equals c, yeah, if c less than k, it means what? That we can make c equals to k by increasing b, by increasing a, or by increasing both of them. So in the example, if like 3 plus 7 equals 10 and we want k equals 11, it means that we can bring either 8 instead of 7 or 4 instead of 3. This way we would have k equals 11. And this is exactly the hint how we can kind of move our pointers, because let's say b is a right pointer and a is left pointer. Whenever we have our sum less than k, if we would have some way to decide whether moving to the right or moving to the left would contain strictly less or strictly bigger number, this is it. It would be the, oh man, sorry, I come later. Can you walk us through the problem description just in fast, if possible, in high level? I'm not able to understand what is the requirement. I mean, I came late. Yeah, no problem. So the problem is max number of k sum pairs. We are given an array and we want to find two numbers which if we add up them and we receive k, we count this operation. And whenever we find these numbers, we are kind of removing them from array, and we keep doing these operations until there is no possible pair of numbers that can add up to k. And as output, we are returning the number of operations we perform. So in this case, 1 and 4 is one operation. We remove them. We have array of 2 of 3. 2 of 3 also is 5. We remove them. Total operations is 2. In this case, it's 3 and 3. We remove them. We are left with 1, 4, 3. There is no actual pair of 1, 4, 3 that can add up to 6. This is the problem we are solving. We already tried brute force, which is n power of 2, and it's not good enough because we are hitting time exceeded. So now let's proceed with our thinking process. So it seems like in case this array is sorted, it kind of would help us in the sense that we know that if we put right index in the end and left index in the left, we always can know that if the sum is less than k, then we for sure should increase left pointer to the right. So how it would work? Let's check it with this array 3, 1, 3, 4, 3. Yeah, let's check it here. 3, 1, 3, 4, 3, and our k equals to 6. Now let's assume it is sorted. So let's sort it very quickly. With this one, this one. So in this case, we will have it sorted, and now we have left and we have right index, and we put it one in the end and one in the beginning. 4 and 1 would be equal to 5. 5 is strictly less than k. So it means right cannot go here because it will be out of range of the array. But we know that for left index, since the array is sorted, all numbers to the right will be bigger than the current one. So we're deciding the greedy approach would be, the logical approach would be here to move index left to the next possible index, which will give us this pair of numbers, 3 and 4, which gives us 7. 7 is bigger than 6. It is not what we want. Now the value is bigger, and since the value is bigger, we for sure know that right index has bigger value, and all the numbers to the left from the current right index should be less than or equal than current right index. Moving left to the left index to the left side of array doesn't make sense, and it is kind of prohibited because this element we already visited. And it means that the only possible kind of move here is to move right index to this position, which gives us 3, 3. This is exactly our 6. And in this case, we should just proceed moving to meet each other, and this would be the end. In this case, let's say there is another 3 here. Let's just assume it is here. And we have this picture. Then we are moving, oh, actually, let's even make it a bit cooler. Let's say we have 4 here. yeah, let's say this is our input array. So we already found this 3 and 3, 4 and 1 are visited, 3 and 3 we already met, we added our counter, and now we moved here. Actually, it's not actually possible. No, it's not possible since the array is sorted. So in this case, you would be here. Sorry once more. Let's traverse this input array again to prove the point. So 4 and 1 would give us 5 less than 6. We know that to the right side it will be more than left current index. We move in here. 4 and 3 would give us 7. 7 is more than 6, which means we should move right index and make it a bit less. It is still the same value. We still keep doing the same. We meet 3 and 3. It's good. We meet our number. It adds up to 6, this pair. We move in both of them. It's again adds up to 6. We count another one operation and we meet the indexes. It's done. That's it. I solved this. Good. Good that you solved it. Now let us solve it as well with this approach. But this is not the end approach. We can do even better. So let's try to prove the point. It will not be all then, by the way. So first of all, we need to sort with ascending order, which means this one. Now we are introducing left to 0 and right to length -1. Again, same approach as with this area in the container, previous question. So whenever the left is less than right, we keep our iteration. And then basically if nums left equals to nums right, this is when we should increase our count, because we found this pair of numbers that add up to, oh sorry, not, oh fuck what I'm doing, plus this one is equal to, let's actually introduce the variable. I think it will be a bit more convenient. Yes. If our sum is equals to k, increase count, and we move in left index forward and right index backward, because this is the point, they should meet each other, and we leave everything behind as kind of already visited thing. Else if sum is less than k, then for sure we cannot move right. We cannot move right backward, because it will give us less numbers since array is already sorted. So we should try to increase left one as much as possible until we reach the k. And another subcase is when sum is more than k, then it should be right minus minus. Another case is when no, there is no another case. So yeah, basically this should be the algo, and we return count in the end. Let's try it. Sliding window should be easy for this. Yeah, this is kind of sliding window, but not exactly. Sliding window would be the next, actually. It will be the next. We will be doing sliding window today. Here you already done hash map where you store all the number in hash map, then loop in big O of 4 1. If we add 4 will be 5. So check if you have 4 in hash. Yeah. I got the point. Yeah, this is the last solution. We will be solving it this way as well. So as you can see, this thing works here, works as expected. Now But okay, also time complexity. Actually, the just sort usually is just JavaScript sort complexity. It is O log n. Do we have somewhere here? Complexity guaranteed blah 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 blah. Okay, just sort. It is using match sort, which is n times log n, and some other sort that I never heard of. Is it match sort? I just need confirmation. Match sort, blah blah blah. No. Complexity. No. Complex. Okay. Oh my god. Java. Okay, let me put this question. JavaScript, what is the complexity of sort? Whatever it is. It should be match sort and it should be n log n, I suppose. Firefox uses match sort. Yes. Team sort. Yeah, this is another thing. So let's assume we are using match sort. And the bottleneck of this algorithm in this case would be the match sort bottleneck, because match sort runs n times log n. As a time complexity and space complexity is O of n, because we are copying arrays. This is just for this line. And now we have our algorithm, which is just traversing array once, would give us O of n complexity, time complexity, and for space complexity we are just playing with variables. It will be a constant time. Since it's big O notation, we are removing everything that is add up and is less. So this one is removed, and this solution is basically n log n and O of n. Can we do better? Actually, yes, we can be inspired by the problem. I think for those who already solved LeetCode a bit, you already know this problem. The problem called toSum or something like this. How it works? Whenever, I think the best one is n log n, which is merge and quick sort. Yeah, but quick sort, it's amortized n log n. I think worst case for quick sort is n squared still. And for merge sort, it's n log n worst case, but we sacrifice O of n space. According to Corman, which I read so many years ago. Anyway, let's think about O of n solution. Why do we need to have n log n, right? It's not that good. So let's say we have this array 1, 2, 3, 4, and k equals to 5. Whenever we're at some character, let's say 2, so this is our left, or let's use pure math. So 2 plus x equals 5. Whenever we're on some number here, let's say at 2, and we know that we should find some x that will give us 5 when we add up the numbers. By math, we can change it in this way. So x then should be 5 minus 1, which should be 3. By using this thinking process, whenever we are on some index 2, what can be done? Basically, we just need to find some number 3 somewhere else in this array. And this number should not be, okay, let's say this is the case with 6. It will be a bit more tricky. When I have this array, and we have 3, so 3 plus x equals 6. by mass, it's apparently x equals 3. So whenever at 3, we should find some number that is 3 and not itself, because if it's only 1, 3, right? Yeah, we will have this number in our hash map, but it's not a pair, it's the same number, so we should two separate numbers. And this is exactly what we're gonna do. So the algorithm itself is pretty simple. We would traverse all the array and collect which numbers do we have and how many occurrences of these numbers do we have. And then we will be traversing array once more, number by number, checking whether there is another number x. So whenever we are at some number num, let's say number, we would be finding some x that by adding up should give us k. So x, k minus num. This is exactly what we're gonna do. Let's try to implement it. So first of all, we should have some map. Then we're just traversing num of nums, and we are putting it to the map. And we're just counting how many specific numbers are right now in the array. So in case of this array, we want to know that there is number 3, and we have 3 occurrences of number 3. This is how we're gonna do it. I can basically show you what will be in the output map, so you just get familiar visually. So this is our map. I'm wondering in the case 2. Yeah, so we have number 3 3 times. We have number 1 1 time, and number 4 1 time. Okay, this is the baseline. This is the map, and we know that operations over map are constant, kinda. Now, what we're gonna do with this map? We're gonna iterate over each number. And as you remember, our formula should be number plus x equals k. It means that our needed number that we need to have in order to make the pair is this one. So this is exactly the formula, and we're gonna put it same way. So let's name it as needed num k minus num. So this is our needed number, our second number that should make a pair. And we firstly check if the map doesn't have this needed number, we just don't proceed. It means we cannot make any pair in the current array. Yeah, just continue. Good. This case is done. Ні, брочик, ще не заїбався. Now, how many? Yeah, Twitch is. I don't know what happened to Twitch, but Twitch is very bad, like very bad. I don't know. Somehow Twitch doesn't work for me that much. So now, since we have needed number, it means that in the array we have presented num and needed that both add up to number k, like this. The tricky part here that we should not use them more than once. So whenever we use some numbers as a pair, we should remove them from array. This is first case. And second case, it can be that the needed is the num itself, and we cannot reuse one number twice. So this is exactly this example when we have, let's say, just this situation, and this is our k. In this case, our map would have 3 that has occurrence 1. And our implementation would return true in this case because 6 minus 3 would give 3, and num and needed would be the same number, and it will add up to k. And we should not count it as an operation because there is only one single tree. How are we going to do it? We're just going to handle two cases when the num and needed the same number or num and needed is not the same. So we're introducing the same var, which is num equals to needed. And then let's introduce some doable, which would tell us whether we should count this operation or not. So in this case, if the numbers are the same, what we should ensure that our map has at least 2 occurrences of the number. So now map has, not has, we already know it has. So we should ensure it's at least 2. Otherwise, if these numbers are not the same, we should ensure that map has both of these numbers at least. We should ensure that map has both of them at least once, so that we have at least one number num and we have at least one number needed. Let's check exactly this thing. So it should be more than 1. And it should be needed also should be presented more than once. But then if doable, we just should increase our count. Yes. I don't know, maybe let's make it a bit better, I don't know. Yes. Yeah, sure. And if we are doing this operation, since we don't want to use number more than once, we should emulate removing the numbers from the array. We should do resetting them up. So we need to tell that we already used it. So we are setting num to -1, and same thing we are performing with the needed number. Yeah, seems to be working actually. Let's try to run it. I'm not sure why we need line num22 and num23, so let's check 22 and 23. I think I already formatted it. Tell me what do you mean exactly? Why you're not sure we need which lines? I can actually try to trace it. Okay. Let me know which which lines exactly you're not sure we need. If we check and found number is on 18, why? If we check and found number is on 18, I think it's line, why we don't just remove that number from the map? You mean here or in which case? I'm not sure. So in this case, if you mean this specific if, why we just don't like decrease removing from map here and just count as operation, because if we should handle it differently in case it is the same or not the same. If the number is the same, we should remove 2 from the occurrences in the map. If the needed number is different from num, we should remove from both of them just 1 occurrence. And yeah, basically this is why. And only we also should check that it is enough. And how we can check if it is enough? Also, it differs and it depends on whether we have num and needed equal or not. Hey, you're welcome, no problem. Yeah, this algo passes as well, and for complexity analysis, this is for the map population we have O(n) plus this traversal is O(n) as well, which gives us basically 2 O(n), which gives us O(n). And for space complexity, it is O(n) as well, because we are populating the map, which is well, actually it's not O(n), it's kinda constant. No, it's not. No, it's not. Yeah, it's not constant. It's not constant because it can be. Yes, it's not constant. So it means it's O(n), yes. If it would be in the character instead of numbers, then it would be constant because it would be O of 26. Good. I'm not sure, is this guy who asked the leetcode question? No condoms, Chris. Are you still here in the stream on the Twitch? If you are, yeah, we can solve the problem you shared. If you are not, yeah, I would just continue with the plan and sequentially would do one by one. So there was some guy who wanted to solve this problem, distribute money to maximum children. Well, we actually solved 5 problems so far. We can solve one more easy and then move to this asked question. And let's see how it goes. So maximum average subarray. You're given integer array nums consisting of n elements and an integer k. Find a contiguous subarray whose length is equal to k that has the maximum average value and return this value. Any answer with the calculation error less than this one we don't care, I think. So this problem is, yeah, we are starting sliding window right now. There is nums array consisting of n elements, and we should try all the contiguous subarrays with the length of k. In this case is 4, and check the maximum and return basically the maximum average in this case. So in this case, if k4, we would try every possible subarray of length 4. This one first, this one second, and this one the last one, and find the maximum, the average in this case. So pretty simple. First we are building our first we should build our sliding window with the average. So let's put the average to 0, and let index equal to 0 while index less than k. We are doing average plus equal nums index plus plus. Yes, and in case of k4, the last index will be 3 here. And we are starting with equals to k. Do we have guarantee that k is less than n? Less than or equal? Okay. Okay. So this would be a sum. And our average would be 0 as well. So we should maintain the sum of subarray here. Because this is how we actually solving the not solving, but how we're calculating the average. We just have sum and we divide it by the number of elements that are participating in this summation. Here we got the sum of the subarray. And now we should, yes, now what we should do, first thing we are calculating the maximum sum, so the maximum average equals max current average and average divided by what do you mean? Sum divided by k, right? Because k is the number of elements. Yes, exactly. Yes. Maybe you want here to start from the same. Why did I? No. What do I do? No. Let me think about it a bit. We still want to maintain our int, or don't we? No, I think we can do it in for loop. Like why do I do this? I don't know. I don't know. So we can do it just like this, pretty much same way. Exactly, pretty much same way. Yeah, and now next for we are starting with let I equals to k minus 1. Yes, I less than nums length. And now what we want to do. So this is the basically sliding window. First of all, we are calculating the maximum average, current average, and sum divided by k. We calculated our maximum average. If we go to our example, this example, so first 4 would give us the sum 1 plus 12 plus minus 5 plus minus 6, which would give us 2. And our max average would be 2. And now we want to slide our window with the same length to the right, to have this one. How we can do it? We should just remove summation of this element and add summation of this element. That's it. So in our case, we should remove the zeroth index, which is, let me think about it. So sum minus equal nums, we have k and we have I minus k. Then k should be actually this one. Yes, and then sum plus equals nums. No. I just wanted, so we don't miss on the edge cases. This is the interesting thing, to not miss something on the edge cases. So just for let's just try. So we can put this line to be extra sure we don't miss it on the edge case. And here let's start from k straight away. K, and here I minus k. Yes. And then return average. So let's check whether it works or not. We're iterating before k is equal 4, 0, 1, 2, 3. Yes, this would be our sum. We are putting average 2. Then starting from 4s, 0, 1, 2, 3, 4. We need to do it in the end. Yes, I minus k 0. Yes, good. Actually, it should work. Come on, what the hell? I know what happened. Reset. Yes. Let's try. Oh, yes, sorry. Good. Accept it and let's submit. Oh, interesting. -1 should be -1 average. Okay, this is interesting. This is interesting edge case. I wouldn't expect this, to be honest, but let's have. So we have array of -1 and we have k1. So in this case, our maximum subarray should be -1 divided by 1 is -1, but we returned just 0. Our sum should be -1. -1 divided by 1, okay. Let me check. Just like this. Let's run it. Yes, wrong answer, but so average in our case is 0 and sum divided by k yeah, I'm sorry, like the maximum, yeah, 0 is bigger than -1. Shit, that's why it doesn't work. So let's put our maximum average to number mean value. I think this is the JS constant for minimum integer. Let's double. That's why I'm solving it in JS, because you can just have 12 and then you can do this number mean value. Not because number mean value, mean safe integer. Yeah, this one you can put straight away. Whoa, yes. Now it should work. Yes, exactly. Good, we are done. Complexity. Time complexity. So since k is guaranteed to be less than n, starting from k, it's actually we're traversing everything only once, which basically gives us O(n), and we don't use anything extra except static variables, which gives us space complexity as constant. Good. So yes, now about the bonus, because I think it's already too late. We are streaming for 2 hours already. You can do it, by the way, if you don't know. On the Twitch, some guy shared the link to the yeah, let's actually show it. You can propose, we can solve something that you particularly want, but I'm bad at leetcode, especially when I'm unprepared to some problem. So no condom Chris. Yeah, he proposed this one as next problem. Let's do it. In the end, also, if you have any questions so far, ask. I'm here for it. Would appreciate any feedback as well. It can be sometimes boring, and I understand, but yeah, just let me know your feedback. So now, what is this problem? I never solved this problem, by the way. This would be the first time, I think, right? Yes. You are getting about easy problem. Should be quick. How about likes? Acceptance rate. Okay, this is very bad sign. This is very bad sign, guys. You give an integer money denoting the amount of money in dollars you have, and another integer children denoting number of children that you must distribute the money to. Okay. You have to distribute the money according to following rules. All money must be distributed. Okay, everyone must receive at least $1. Nobody receives $4. Well, money 20, maximum number of children with $8 will be... Oh, wait. Return the maximum number of children who may receive exactly $8 if you distribute money according to the aforementioned rules. If there is no way to distribute the money, return -1. Okay, I didn't get the problem like exactly correct. Let's see. The maximum number of children with $8 will be 1. Okay. One of the ways to distribute money is $8 to the first child, $9 to the second child, $3 to the third child. Can be proven that no distribution exists such that the number of children getting $8 is greater than 1. Return the maximum number of children who may receive exactly $8 if you distribute the money according to the aforementioned rules. And everyone should receive at least $1. Nobody receives $4. I think this is more like math problem at this point. There is some math justification of proving this to happen. But let's think. First of all, like let's start with the most brute force thing we can do. So we should give each children at least $1. So it means we should straight away subtract the number of children from the amount of money. Then nobody receives $4. This we should maintain, and then we try to get to give as much as possible children $8 until we don't have any more dollars. But then, yeah, but then we should maintain that 4 is not given. Interesting. Okay, interesting. So in case we have $20 and 3 children, we straight away we should reserve something for to meet this criteria. But well, wait. Nobody receives $4. This is the tricky one. This one I'm not sure how I can guarantee. All money must be distributed. Everyone must receive at least $1. Nobody receives $4. This is interesting. And we should return. I'm also new to leetcode. I love the way you break down the problem. I would love to join your next stream. May I know when you stream again? Yeah, sure. Most probably I will be streaming next weekend. So yeah, I'm not that good at leetcode as well. If I just, yeah, sometimes I'm struggling a lot with the problems. I'm struggling a lot. So let's try to solve it. If we reserve at least 1 for each child, or can we just straight away start with 8? 8, it's 16, and we have. Yeah, in case of 3 children, if we try a greedy approach and we give each child 8, second child 8, and we left with 4, and third child will get 4, and it's bad, right? We don't meet the criteria. Can we use somehow the reminder? So when we have 4, okay, what if we just, yeah, let's use the console instead. So 8 is divisible by 4, right? So it means we should be able to do this. 20 divided by 4, it's 5 children, right? By 8. Okay, and if it's, yeah, okay, actually I think I come up with some solutions. So we can use the modulo operation, which gives us a reminder after the division. So we first try to do modulo operation on 8 and see, because our goal to get as many as possible 8s to each child. This way, how we can answer this 20 divided by 8. So 2 numbers in this case, 2 children, 2 child can get the 8 money, and then we have a reminder of what will be the reminder of money after that. Well, yeah, interesting. the reminder would be 4, and if it's 4, and in reminder we can have only, yeah, it means we, if the reminder is 4, okay, let me try, so let me try. So basically there are a lot of edge cases, guys, fucking a lot of edge cases. So I hope money is money more than children. No, we cannot guarantee it. Fuck. Okay, let's work with edge cases. If money less than 8, we should return 0 straight away. Alright, am I correct? Maximum number of children who may receive exactly $8 if there is money according to, yes, it's straight away 0. Good. Now if money is more than 8 or equal to 8, this is when we already start to think. Let max possible. Okay, let's just introduce variable max, which would tell us how many children we can fit with the $8. And it will be money divided by 8, and since it's JS, it will return double, so we floor this value to the lowest. This is the maximum amount of children that can receive it. And now the question, because if there is some reminder, all money must be distributed, so we don't have to have any reminder. So let reminder money modulo of 8. If there is at least some reminder, we should just do max minus minus, sorry. If reminder not equal to 0. What is the thinking process over it? So let's say there is three children, right? And we want to give as much as possible 8s. So this thing would give us one child would get 8, second child would get 8, and we have reminder as 4. Oh, yeah, we have reminder as 4, and it means that third child we cannot give him this reminder, right? So we should distribute it and remove one of the 8s. Yes. But one case when it should be okay is reminder is these two should pass basically. I'm sure they should pass. No, they did. Yeah. Max. This is mass problem actually, I think. Yes, but there is edge case. I think when reminder, when there are more children. Yes. It's interesting because if there are more children than we can actually afford, children more than max, let's say we have 4, 5 children and maximum we can afford 2. Oh, it's actually a very interesting problem. Okay, this one would fail, but I want to see at least some test cases by which we can check. Yeah, for sure. When money is 1, children. Yeah, we should even return -1. It's impossible. Interesting. Let's see. Can we distribute the money according to rules? If we give occasion exactly 8 numbers. What are the hints? Brute force to find the largest possible value. Okay. Okay, this one is interesting. Yeah, I see the people is not I see the people are not that happy with this problem. I think to not waste any more time. I think it's a bit late. We can I can leave it for next time. I will prepare and let's see. But for now, yeah, it seems a lot of edge cases that yeah we would end up solving. And I don't want just to waste just half an hour of solving these edge cases and stuff. But interesting problem. I don't think there is big rate of like, and this is the case, guys. Whenever you see some leetcode problems, I will show you how to prepare to the interview questions right now. So whenever you see the problem, you should straight away check the ratio of likes and dislikes. It is very important. And can we see it actually? Or we can only see ratio of likes? Before, I remember that before in leetcode we were able to see the ratio of the likes and dislikes. Or yeah, other thing how you can do it is to check the acceptance criteria, which is kinda correlated with the ratio of likes and dislikes. I think it is correlated. Before it was. Now I cannot see how to check number of dislikes in leetcode question. Or they follow the YouTube approach. Okay, anyway, yeah, then we should follow the acceptance criteria, and you can see in this problem that the person pasted the acceptance criteria for easy question 20% is very bad. It's very bad because, for example, if we take any of the easy problems, let's say here it's 54, 58, 60, 40, 50, 50. So usually easy questions should have like above 50. If it's not, well, maybe there is some problem. Okay, anyway, thank you for being with me. I hope I answered all your questions. Thank you for being with me as well. Next week we are streaming again. For sure we are streaming again. Yeah, I will be preparing. We will be following this leetcode 75 list. Also, we will solve this shit. I will solve it offline and bring the whole pane, so you just don't waste your time, guys. I'm respecting your time. And yeah, So I think that's it. Now the only thing I would ask you is to subscribe to my social media right now, which will be popped up here. Yeah. And that's it. I would say thank you for watching. Thank you for being with me again, and see you next weekend. I think I would upload some new things to the channel, some new LeetCode problems or something about Microsoft. I don't know. Let's see. Anyway, subscribe to the social media. I will keep you updated there. See you guys. Bye bye.